Thank you. I think we'll wait 2 or 3 minutes and we'll start. About previously we were discussing about Python, right? So Python is the main programming language people use to do data science or AI stuff. So we'll get this is the main programming language we need to learn to work in data science. There are different languages also, like might be Julia or some R programming languages can also be used for data science, but I'd say 90% or more than 95% of people are using Python. So that's why we are starting with Python programming. Okay. So yeah, Python was this Rossum was the person who created this Python programming language. So previously it used to be for backend similar to JavaScript stuff. Then slowly it got evolved and many people are using for data science. This is his motto: how to create a good programming language. So we saw this some addition and things like that, right? Previously. So yeah, so integer, floats, and strings are different type of data types we have. Yeah. So we are equal to is used to assign values to variables. So there's different naming conventions we generally use. So any variable should not start with a number. It should either be a letter or this underscore using. So in Python, the underscore is generally it's not I would say compiled or rendered. You can use underscore most. You will see most of the places people using underscore rather than spaces to separate words and things like that. So here are different these kind of things you can do underscore b underscore 2, and if you have requirement saying that the first one should be a number, then you can do underscore 2 underscore bob. So, yeah. So there are few words that are reserved. There are about 28 of them. So I'll just read them out once. End, assert, break, class, continue, def, del, else if, else, except, finally, for, from, global, if, import, in, is, lambda, not, or, pass, print, raise, return, try, while. These are like 28 things that will not use to place them as variables because they are used to define things like. Yeah. So these are the naming conventions that generally programmers use. You can, it's not compulsory that you should follow the all caps for classes, camel classes for pre-existing stuff. It's just like conventions programmers use. So previously, we were saying we were using X common and this kind of compressed notation, right? Okay. Yeah. So previously, we saw different data types that are available: numbers, booleans, and strings, floats, and stuff, right? So now we'll see different containers, how we store different data types. Oh yeah. Let's say suppose let's see here. So let's say we have x comma y equal to 2 comma 3 x comma y. So you can see here x is given the value 2 and y is given the value 3. So if we want to swap these things, either we have to do something like initialize like a temp equal to x. Now x equal to y equal to temp. Now print x comma y. So now this thing swap the 2 comma 3 into 3 comma 2. So rather than that, we can directly say x comma y equal to y comma x. Print x comma y. So we'll do this before this thing and after. Yeah, see, so initially x comma y is 2 comma 3 comma 2. Then after this swap thing, it went to 2 comma 3. So rather than initializing a different variable, we can directly swap using this format. So if we don't assign anything, it would say y is not defined. So there are 3 different data types available for us: tuple, string, and list. So the main thing you have to remember that tuple and string are immutable. List is a mutable thing. So what is immutable and mutable is once we assign a variable, means things like say tuple equal to 3 comma 4. We can't change the entries in that tuple. If you want to change, we need to reinitialize the tuple. Similar to string, but in list we can keep adding elements into the list. I'll show. So yeah, so the square bracket, x equal to list, x equal to list, type of xx. So here we are initializing a variable xx with an empty list. Square brackets say that it is a list. So here you see this type of this thing is list, initializing with a square brackets. So the indexing, so here we have xs is equal to 3 1 2. So we are creating a list called xs with 3 entries in it. So if we want to say, we'll run this print, we are saying print xs. So now we got this list. Now print xs of square brackets 2. Any idea what this is doing? Okay, so indexing of a list prints index values. Yeah. So now say let's take this. Print xs 1. Let's say 2. So it is printing 2. So here, so we are trying to print the index 2, and it is printing 2. So if our indexing starts with 1, it should like this is the first element, second element, third element. Where we are trying to get the element with index 2. So in Python, the indexing starts with 0. So this is the 0th element, this is the first element, and this is the second element. So if we put, if we will take 0, it will print 3. See, So in Python, indexing starts with 0. If you are familiar with MATLAB, in MATLAB indexing starts with 1. So you have to take care of that. So yeah, so if we want index of a second element, we'll put 1. It is giving 1. If we put index of the second element, index of the third element, we'll put 2. By practice, you'll slowly you'll get familiarized with this indexing thing. So this is the 0th element, first element, and second element. So similarly, we can say suppose we have things like this. Over here we have some values. Some value 7, 6, 1, 4, 4, 2, 0. So we have this number here. So this is the 0th element. This is the first element. This is the second, third, fourth, fifth. So similarly, from start we have 0, 1, 2, 3, 4, 5, right? From back also we can say this will be minus 1. This will be minus 2. This will be minus 3, minus 4, minus 5, minus 6. Let's now copy this thing into our code. So some L equal to a list of 761420. 761420. So as we saw, if you get the 0th element, it will be L of 0. It will give 7. So if we have minus 1 here, so if we put minus 1 instead of 0, it will print the last element. Right, see, the last element is 0. So rather than if we don't know the length of the list, but we want the last element, we can directly put minus 1 rather than going through what are the numbers of like finding out the length and then saying fifth element is the last element. We can just directly put minus 1. It will index from back. Yeah, so now we have a list of numbers, right? Each entry is a integer. Let's print the type. So here we have print of minus 1. Let's print what type it is. So it is each thing is an integer. So now let's take in this let's remove this 0 and we'll put last, a word called last here. So to get the last element, we will do L of minus 1, right? So now L of minus 1, we are assigning new thing. Let's say last, last, and print L. Oh, before we do this, and after this thing. So see, previously it was this thing, and then when we put L of -1 equal to this part, we are assigning the last element. We are changing the entry in the last element to this thing, some string here. So indexing, and we can replace the elements in a list. This is called mutability. So list is a mutable data structure. This is the same thing we saw. So we are rather than having the indexing to the last element, if we want to add something to our list, then we can just say access dot append. Dot append is a method available for lists to add things to the end of the list. Here we say, let's see. Now after this thing, I will say L dot append age, something called like this. So here previously it is this thing, then we are adding this something called age at the end of the list. To get a single element, we saw, right? So we just give the index of a single number. It will return us the entry in that thing. So here we are initiating the variable called nums with into a list. We can write a list like this in a square brackets. It will also create the same thing. So x equal to list of uh, x comma type of x. We gave this string, and we are trying to convert that into a list. So each letter is being converted into a single element, and we see the type of the list is sorry, the type is list. Rather than giving the square brackets, you can also do this thing. Now list equal, we created a list with a range of values from 0 to 4. Now this range is a built-in function similar to type and length previously we saw. So slowly you'll understand the built-in functions. Yeah, list, we're converting creating a list containing 0 to 4. Since we have 5 here, so it will start from 0 and give out 5 elements. So 0, 1, 2, 3, 4. So we printed this thing. Now we are indexing 2 to 4. So what is the second element? Say 0, 1, 2. It will take the second element, third element, and it won't take the last number we specified. So it will give second and third one. Here, see, here we have the answer. Now if we want we are saying from 2, we need till end. If we don't specify anything, it will take till end. So here, see, from 0, 1, it starts from 2. 0, 1, 2 will be, 3 will be there, 4 will be there. Since we haven't specified anything here, uh, it will go till end. Similarly, if we don't specify the start, it will take from the 0th element. We said from 0 till 2 excluding 2. So 0 will be there. So this is the 0th element. First element will be there, and the second element will not come as an output. So here we can say 0 and 1 will be the output. Here you see. So 0 and 1 is our output. If we don't give the initial and the final thing, it will take from the first and it will give out the last element. Here you see. So it went from 0 to 4. Similarly, if we say minus one is the index of last element. So num of nothing is in from 0 till the last number, not including the last. So from 0 it will go to 3. 0, 1, 2, 3. It won't take the last index. So now we are assigning similarly here we saw we are to put some a value at the last, we put the last number and assign directly the value, right? Here also we can if we want to change not not a single one, you want to change different things at a time from second element till fourth element excluding the fourth. So second and third will be replaced with 8, 9. So second element is 2, third element is 3 before before this assignment. After the assignment, it has changed to the second two element is 8 and three element is 9. So now we saw this thing. How to slice, how to go through a list, and how to get things out of the list. So list can be contain any data type. Or list can contain another list inside it. Doesn't matter what anything can be inside a list. So let's have some variable called animals with the cat, dog, and monkey. So to print all the elements in this, we'll just say for. So this is a for loop. It will continue till the end of the iterable. So list is also a iterable. So iterable means you can go through these things and loop. So there are more than one element in it, and you can iterate through things. So for animal in animals. So for some variable here in some iterable. For some variable in some iterable. We'll go this iterable here is our list. So we are assigning in first loop it will go for animal in animals. We are trying to print animal. So for first it will go into this thing will return cat. So it will print cat. So in the second loop it will return dog. This third time it will print monkey. So this is the syntax for loop. We need this for some element, some variable here, the keyword in, and some iterable here, and we'll end with the semicolon. And you might have used flower brackets to create loops in some other languages. Here we don't have that thing. Here just this using spaces. We do our indexing. So see here, this also prints out. So this index should be there. So let's I'll print. I run without any index. So spacing before. See, it is indentation error. It is showing indentation error. What if I put like this? But see here by putting like this, we have the result here. We either do like this if it's just a single line. We don't have much logic here. Or else if we want more logic, we'll just say we'll put some space before. We'll indent into inside the for loop. So yeah. So this is one more function available for us, enumerate. So some here we have some variables and in some iterable. So what does enumerate do is previously while doing this for loop, we just got cat, dog, monkey, right? So enumerate returns two things. First would be the index and second would be the animal. Now let's print this. Okay, see here we got this thing. I'll show you what. Let's copy this part. So yeah, rather than saying some two variables, we'll give just for some variable x. in enumerate of animals. Let's say print X. See here, we got index is 0, cat, index of 1 is dog, index of 2 is monkey. So this returns along with the number. We just, if we want the number, we are giving. So previously we saw, right, to assign something. So this is returning two values. So 0 comma. So we have idx comma animal equal to this thing 0 comma cat. Rather than saying index equal to 0, animal equal to cat, we are directly assigning two variables, two things directly. So that's why this kind of format is useful. This is specifically in Python, it is very useful. Most of the time you will be using enumerate function, so that you will, along with the value inside the list, you will also get the index. So list comprehension is a thing like if we want to write a loop in very small, it should be very readable and very small. So suppose we have a list called nums from 0 to 4. We initiated an empty list called square. When we want to have the values of squares of this thing inside the square. So first for loop, we'll write a for loop x in numbers. So it will iterate from 0, 1, 2, 3, 4. For each iteration, each value of the each element in this value will go into x. Now what we do, we want the square. How do we square number? We'll just put two stars, right? Two stars and 2. This is power and 2. So we have the value x square here. And to this empty list, each loop we are trying to append. So this squares is an empty list. In each loop we have squares dot append the square value. And finally we are printing this out. Okay. So this print statement is outside the loop, right? So suppose if we have this print statement inside the loop, let's say print statement inside the loop. So now you will see. So initially 0 is here. The value of x is 0. Then we squared this. 0 part 2 is 0, and we are appending that to squares. Initially, what is squares? It is an empty list. So for one in empty list, we are appending a number called 0. Now, after this is run, we are printing that squares list. Now, after the loop, next value will be 1. So 1 will be squared and will be appended here. You see 0 comma 1. Again 2. 2 square is 4. Now after that 9. Now 16. You see, right, how by each thing we are squaring it and appending it to the empty list. The same thing can be done in single line. So initially we have this thing, numbers list. So we are saying for x in numbers. Okay, we have x in numbers. It will loop. What we want to do? We want to square that element. So we will put that logic first. X square for what is x in numbers, right? So for x in numbers, we will square it. This will be the logic, and we will enclose the whole thing in square brackets. It will create a list directly. So this is just to like make it x square for x in numbers. This will form a list of squared elements from the elements in the list numbers. It will give out the same thing. So yeah, it can also contain conditions and things like that. You can keep on adding to this thing, but at some point, it's like it's very simple to write have small things. Slowly, if you have 4 or 5 logic elements, it will become a horrendous like a long text. Rather than doing that, you can write a small loop. If you have a very short thing, you can use this list comprehension. So yeah, now coming to next data type, we have dictionaries. So what we in a dictionary, we have say suppose this is our dictionary. What does a dictionary have? We have a word, and we have meaning of that word here, and we have again some word and meaning and things like that. Something here and this thing, right? So this part, the so this part is called the key, and this thing is called value. So for each key, we'll have some value assigned to it. This is the structure of some dictionary. So to represent that, previously we had square brackets, right? Square brackets are for lists. So flower brackets will be for dictionaries. So x equal to this thing, your initiating print type of x. So it is saying the dictionary type. So to have things, we can use this. See, we'll open our flower bracket. We have our key. Right. So the key is cat, a string, and the value is cute. The key, one more thing is dog is the key, and the value is furry. So previously we used numbers to index through list, right? So now in dictionaries we'll use the key to index through the elements in the dictionary. So if we let's run this. So, yeah. D equal to this list this dictionary we have created. So D of square brackets of cat. So we are putting cat. Cat is the key for value cute, right? So it is returning the value cute here. So if it is a list, we'll have D of 0. 0, this will return the 0th element. If we have 5, it will return the 6th element, like things like that, right? So here we have some key value assigned to thing. Rather than going through 0, 1, 2, 3, 4, we have some key values that can be assigned so that we can iterate through. And see, so cat in D dictionary. So in is like checking. Is cat there in D? If it is there, it will print 2. Let's say some dog. It is returning true. Sorry, I put dog. Dog is there. Now let's say rat. Is rat there in the dish? It is returning false. So this is the key value pairs. So if we want to add anything into dictionaries, we can directly say D of new thing. A fish equal to wet. It will directly add. Previously, to add elements into list, we did the dot append, right? Rather than doing that, we can directly assign some key and then the value here. It will directly add into the list. What we try to see, monkey is not there in the list. It is showing we're trying to get the value for monkey in the dictionary. It is saying key error. There is no key called monkey. Yeah, this you don't have. Dot get is to get. This is a similar syntax to this. You don't have to worry about this. So the main use of dictionary is it is easier to iterate through the element, through the values we need. And one more thing you can think of it is like a list is not hashed. Key dictionary is hashed. So hashing is a process in which it is basically a hashed function is very fast compared to unhashed function. This is like it is some depends on our variable, like how fast can things can be processed by our laptops and things like that. So dictionaries, indexing through dictionaries is very easy when compared to lists and things like that. One second. Laptop is not charging. To charge. Yeah. So here we have some dictionary d equal to key is person 2, cat is value 4, spider has value 8. So this is our dictionary. So for animals, animal comma this d dot items will return an iterable. I told you, right? For some variable in some iterable. So to if D was a list, we will directly put a D here. Because we want the dictionary, we need to put D dot items. This will convert the dictionary into a iterable, and with each iterable we have the key and value. Yeah. So the animal is key, and the value is number of legs. Now we are iterating through each thing, right? So we have we'll print a person has 2 legs. So we in the previous class we saw for a string we to put the in these flower brackets inside. If we want to put anything, we'll do dot format and things we want to put there. So for this first flower bracket, we have animal. So here, what is our animal? For the first thing, we have person. A person has 2 legs. A cat has 4 legs. A spider has 8 legs. So this is the format. So similar to list, we can also do dictionary comprehensions. Yeah, this is just to compress everything into smaller, so that it's a bit easier to understand. Now coming to sets. Sets is like it is the similar thing that we have learned. So a set is so S equal to we write right some set 1, 2, 2, 3, 4. So if we want to add LMS plus 5, so then it will be a new element 5 will be added here. If we want to do S plus 1, since 1 is already there in that set, it won't do anything, right? This is set of all the things we have. This is a similar mathematic notation we generally have. If we don't have any key value pairs, if we just put values, it directly converts into set. So this is the same syntax, similar syntax for dictionaries. The only difference is if we don't provide the keys, it will directly convert itself into set. Or else you can put some x equal to set of 1, some element. Yeah. So Python doesn't have a empty set. We initially have to create a single set. So we have an animals as a set, cat, comma, dog. Is cat there in animals? Is fish there in animals? Yeah, it is there. But fish is not there, so it is returning false. So to add animals dot add fish, print fish and it will return true. Yeah. The length of animals is 3 after adding the cat. So even if we add cat again, it will, since a cat was there previously, it still it doesn't bother with it. If we remove cat, it will remove the cat from it. The same way you can iterate through the same way we saw for loop can be done in the same format. So here this is something new here. So Python has some modules pre-built into them. One of that module is math. From math, we are importing square root. So we don't have to write a function that returns a square root. Someone has written it and a bit efficiently, and they have provided. Python itself provides with some math functions. So here we see print square root of for I in range int square or x in range 30. Any doubts what's happening here? Do you understand what's happening here? Print int of square root of x for x in range 30. So see, now I'll show you. For I in range, now let's, since it is a comprehension type, we'll write out everything. For x in range 30. Let's print what is x. So x is from 0, it is going till 29, since we said the last number won't count. Now we have for each value of x, we have some value. Now what are we doing? We are square root of x. Now let's print rather than x, let's print square root of x. See, the square root of x 0 for each element, we have different numbers, right? So now after that, we are converting each value into int. Now let's take the whole thing. See, the integer will convert that float value into int. 0, 1, 2, 3, 4, 5, 6 till 5. Now we are saying we are putting the whole thing into a set, right? See here, this whole thing. If we see here, this is just flower brackets. In flower brackets, we are putting these things. These are all numbers. So 0 is there. We'll get 0. 1. Okay, 1 is added. Now next again, 1 is there. Since previously 1 is there, we don't do anything. Again 1. No. Now new element 2 has come. So 2 is here. 2 comes so many times. And yeah, these all things will be, you understand, right? So these are the whole things. We are converting this whole thing into a set. So it will remove all the repeating values and it will just give us a set containing only these values. This whole thing is done in simple one-line format. Yeah. So yeah. So let's sorry for that. So we have tuple. Tuple is one more data type. This is immutable. So immutable means we cannot change it after once we assign things. So here, so we are create a tuple 5 comma 6. Yeah. So type of t is tuple. Print t of t. So 5 comma 6 is similar to printing d of this 1 comma 2 as a tuple. So we cannot index in tuple. So this is showing some error because uh, tuple object does not support item assignment. We cannot assign. Previously, if this t was a list, if we wanted to change this 0th element to 1, we can directly put some L of 0 equal to 1. But once we assign a tuple t equal to 5 comma 6, we can't change that. Let's see. Let's print t. So now the tuple is 5 comma 6. So if we want to see, if we want to see the first element, we can say, okay, t of 0. Show me what is there in 0th position. It is there 5. But we can't assign a new value in that position. You have to reassign everything. So that is the format of the name for like mutable and immutable. Is similar to the same stuff in C and Java. Now coming to functions. The syntax for function is the minimum things we need is this def. This is saying that we are defining a function. Here we have to have the name of that function, and here and in a square bracket. So this is the minimum requirement. The def, name, and sorry, not the square bracket. This parenthesis and this colon. This is the minimum requirement. If our functions takes any arguments, if our functions take any arguments, we can put those arguments inside this bracket. So sign, let's write a function that will tell us the sign of this value that we give, that argument we give. So if x greater than 0, this greater than, less than, or equal to, this is the same format. So if some condition and semicolon, then it will uh, uh, Python will go into this only if this condition is met. Else it will move on to the next thing. Else if x is greater than 0, return positive. So this is the syntax. Return positive. It will return positive. Else if x is less than 0, return 0. So the remaining only thing is 0, right? So if statement, then or else if statement and else statement. We can just have if statement. If we want else, we need if and else. If we have more, if we have if else, if else, if else, then we can directly write elif. It will check for this, and then check for this, and then finally go to this. So we are we are writing for x some variable in some iterable list. We are iterating through x. So first we have value of print x. Yeah. So first we have value of x minus 1. So after that, what we are doing, we are printing sign of x. So this is sign function we defined here, right? Sign. Oh, and we are giving the arguments minus 1. So it is minus 1 will go here. Is minus 1 greater than 0? No. So this is gone. Is minus 1 less than 0? Yes. So it will go into this. Returns negative. Now we are printing whatever this function returns. So it returned negative. Now next, it will go to 0. 0 will go here. So sign of 0. Sign of 0 is if 0 is greater than 0, no. This is gone. 0 less than 0, no. Then finally else return 0. So it finally came into this part and returning as 0. Now next it is the value of 1, right? So we have directly comes here. If 1 is greater than 0, yeah, it is true. It is directly returning this and ending the function. It is directly printing positive here. So we generally use two kind of arguments, named arguments and key value arguments. So, by putting equal to sign in this definition, we are saying that loud is equal to false unless specified in any other ways. We are giving some default values for our thing. Yeah. So def hello name. This is one function. So for function, we need some def name of the function, a place to put our arguments, and semicolon. Inside this function, we are writing if loud. So initially we put loud equal to false. We are giving this variable. If loud equal to false, if loud, if this value is true, then only this will go right inside. If true, print hello and format into uppercase. If we want to shout it, like we are putting try to name dot upper will convert all the things into capital letters, right? Or else uh, if uh, if this is not false, this is if false, then it will go to else, right? This part, if this value is false, it will next go to the next thing. So here we are giving one name. So this name will go hello. This dot format will put the value name inside this flower bracket. If you want to put it in all caps, you are doing name dot upper. This whatever name we give, it will be converted into all upper cases and will be put here. Or else it is just dot format and we'll just put it inside this thing. So to call this function, we'll put the name of the function and just write our whatever thing we want here. Just print this. Here we have hello Bob. Since we did not specify anything of loud, the default argument is false. So this part of code won't run. It will directly go to else and it will print this. So say here we have Bob, nor hello, comma Bob here. If we have the function, name of the function is hello, and we have variable name, where name, and the second thing is we are saying loud equal to true. Then see what we see here. If loud is true right here, now this part of the function will be executed. That's it. I think we can conclude it for here. Next time we'll see what are classes, what are methods, the whole object-oriented programming thing we'll see in the next class. If you have any doubts, type in the chat, or else you can leave. You can unmute yourself and ask me questions if you have any questions. Also, you don't have to type. Yeah, I will share the link in the group. I'll share the whole collab notebook. Nah. Yeah, thanks. Thank you guys for attending.